Hey guys, it's me Prince, and as you know that we have already gone through the architecture diagram and the coding part of our Solana Escrow. So the last bits remain is to how to test it, right? Testing is very important and it helps us to find bug in our contract and any other problem that we may face. So it also helps us to test all any edge cases if there are in your contract. In any test for Solana contract, there are like 3-4 stages that we go through. The very first stage is to setting up the stage. Now you will ask, Prince, what do you mean by setting up the stage? So by this, what we mean that we we have in the contract, if you remember, we had different kind of requirements. For example, we had two users like user A and user B. So in contract version, user A and user B simply means that we have two private keys public keys pair, right? After that we had a contract. This contract had a PDA, this contract had a ATA. So apart from that, we had two mint that were being traded in escrow. So we also need that mint here. So we need to derive everything from scratch. We have to derive the private key public key pair for A, for B. We need to derive like we have two mint addresses, right? Mint A and mint B. We need to derive ATS for both of them. We need to derive ATS for B of both of them, and then we have to derive mint too. We have to like create tokens. So first thing that we are going to do is to derive everything we need. After that, we will airdrop shoal and the amount of token that we required for the trading. After that, we can directly get into calling instruction and testing it as a story. By this, what I mean, we call instruction accordingly, right? So we call first make instruction. So if you remember in our story of trading, in the architecture diagram discussion of our uh, escrow, what we did, we first created the make, like we first make the escrow, right? So you cannot call refund instruction or take instruction without calling make instruction, otherwise it would fail, right? How can you take from any escrow which does not exist? How can you ask to refund any escrow which does not exist, right? So we do it in a format that it flows, the instruction flows as a story, right? So let's get on to it. Decide what token program are we going to use. If you see, we are using token 2022 program, which is coming from Solana SPL token. After that, this is the seed that we are talking about. If you remember, we had a unique constraint in every escrow that was a seed, right? So that seed helped user to create multiple escrows. So if you notice that it is just a 8-byte random, which we are converting into a big number, which we'll use as a seed for our escrow. Basically help us to log the instruction, and this will help us to like confirm the signature or confirm the transactions. After that, if you remember, we needed 4 private keys public keys pair, right? Maker, taker, and mint and mint B, mint A and mint B. Later down in the instruction, we'll convert those mint into real mint addresses. Like this is just a private key public key pair right now. Later we'll convert it into real mint addresses. After that, if you remember, we needed 4 ATAs, right? 2 ATA for maker and 2 ATAs for takers. So that's what we have here. So we have maker ATA A, maker ATA B, taker ATA, taker ATA B, and we are taking maker taker and we are mapping it with mint A and mint B. So what will this do? This will take maker and call this function once with mint A. Similarly, this will take maker and call this function with mint B, and then taker with mint A, taker with mint B. So we'll have 4 ATAs: maker ATA A, maker ATA B, taker ATA A, and then taker ATA B. That's what we need, right? And here we flat all of them. So we get all of them in a single function. You don't need to, or if you want, you can call multiple functions or make a function and then call 4 times, whatever it's like easier for you. After that, we had a PDA, right? So if you remember, the seeds for PDA was this. It was a simple string called escrow. After that, it was maker key and this random seed that we took, the random seed that we are deriving over here, right? So we are using same stuff to create the escrow PDA. So this is the function that is used to create or derive PDA. Public key dot find program address sync, same stuff, buffer from escrow, maker public key, and seed to array like. And LE, if you remember, in the contract also we were using little Indian bytes. So here also we are using little Indian. And the question is, why are we using 0 over here, right? So when you call public key dot find program addressing, it returns you two stuff. First one is the derived PDA and the second one is the bump. So we don't need bump over here because our anchor derived bumps for us. So we are just taking the PDA and then moving along. After that, if you remember, we had an ATA for escrow also, where we stored fund, right? Where we store fund after user A calls instruction make, right? And when take instruction is called, the fund is released from that ATA, and we called it a vault, right? So we call same function get associated token address because it's an ATA, it's not a PDA. Remember here also, if vault has been a PDA, then we had to create it just like this by calling this function public key dot find program addressing. But since it's not a PDA, it's an ATA, we are calling this function directly. And what are we passing in the function? That is mint a dot public key. And the second instruction, like if you look into the definition of this function, first instruction, first parameter is mint, second parameter is owner, and third parameter is allow off curve or not, and the last parameter is program ID. So mint a because we are going to store token a into the this vault, right? After that, if you remember in the contract also, we gave the authority of this vault to escrow. So the owner is escrow. Now what do we mean by allow off the curve or not? So the owner of this ATA is not a private key, right? Yeah. So allow the owner account to be PDA. If we pass this true, then the owner can be a PDA. There is no strict requirement that owner should be a private key only. So since we are not deriving this vault for any user, we pass this as true. After that, we give the token program. If you remember, we derive or like we declare a token program in the beginning, and we are using same token program everywhere. So this was also a strict parameter that across our entire contract, the token program should be same. Otherwise, our our instruction will fail, right? Now we collect all the accounts over here. Why do we need to collect all the accounts? Because most of our instruction need all of them, right? Most of our instruction need maker, taker, mint A, mint B, maker ATA, all the maker ATAs, escrow vault, and token program. So these are the accounts. So we collect all of them here. We'll pass the entire accounts to each instruction. Now, this is something unique. You might have not noticed it in the previous testing. So if you remember, we had events, right? So our each instructions emitted an event. Here we are gonna listen to those events and we are gonna log them. So we create a listener ID, and so this before function does what? This will, even before we call any function, after like any instruction we call, this will call this function, and this will make all the event listeners ready for us. So we had three events, right? Make event, refund event, and take event. So that's what we are doing. We create listener IDs, and then we make event listener, and then we push it here. After that, we create a refund listener and we push it in here, take listener and push it in here. So we have all the three listeners ready, and what they are doing, they are just listening to the emitted events, make event, refund event, take event, and they are logging. What they're logging? They're logging what exactly was the event, what was the slot of the event generated, and what was the signature of the transaction. After that, the second part of setting our stage, that was to airdrop. Like we required Solana um, to call all our instructions. We required two different kind of mint addresses to call these instructions. We required tokens in our account in order to make an escrow to call take instruction. That's what we are doing over here. In order to create a mint account, you need some rent exempt for mint. That's what we are calculating over here. After that, we get a transaction, and in the transaction instruction, what we are pushing, right? The first thing that we are pushing is we take maker, we take taker, and we transfer 10 Solana to both maker and taker. After that, we take mint A, we take mint B, and we create those mint addresses here. We are taking both mint, and then we are creating mint out of them. We are taking mint public key pair, and then we are creating mint from them. After that, we are creating ATAs from them. The decimal for our mint is 6, but we are minting 1 to the power 9. That means like 1 to the power 3, like 1000 tokens in each account. After that, we send the transaction. Now, one by one, we are gonna call all our instructions. First one is make instruction. So we take program.method.make. First, what are the arguments that it need, right? So if you look into make instruction, you can see it exactly here. So these are the arguments. It needed seed, it needed deposit amount, it needed receive amount. What are the accounts it needs, right? So make needed maker, which was writable. I mean, that was writable and as was signer. After that, if you look into the ideal of our instruction, you will find all of them. So we pass all the argument. After that, we give our accounts, right? So if you remember, in the instruction, we gathered all the account in a single variable, and we are passing all of them here directly. So you don't have to pass one by one. After that, to call make instruction, there was one signer required, that was the maker. So maker is the one who call make instruction, right? After that, we do dot rpc, and then these are our two helper functions that we use, right? One was to confirm, and then one was to log the instruction. After that, we can either call refund instruction, or we can either call take instruction. So this should be like simple, right? If you call refund instruction and after that you try to call take instruction, this should fail, right? That's why we have like catch and throw error over here. So if you want to call make and take instead of calling make and then refund, you can do xit over here. So we will try to run this test twice. Once we'll try to call make and then refund, and after that we'll try to call make and then take. After that, we clean up all the events that we had. So let's try to run it. We're gonna do Surfpool start watch. This will ask us which program we are like supposed to start Surfpool for. We're gonna select Escrow anchor. We can like put the default name, and we can deploy the same stuff. After that, let me look for the program on if we have something here or not. Yeah, now we have it here. So if you look into our program, it shows, right, it's executable. That means it's a contract deployed. The code is anchor test. We can do a skip build. So this will first try to, yeah, this first called airdrop treatment. After that, it called make instruction, it called take instruction, and let's try to like call refund and make. We can look into all the instructions if we want into the Solana Explorer itself. Yeah, we have take over here, and similarly we have make over here. We are calling make instruction over here, and we are calling take instruction over here. It's amazing, right? And if we try to call all three, right, make, refund and take, it should fail, right? Because we're trying to make an escrow, and even before we call take instruction, we're just refunding, and that means this escrow does not exist while we call take instruction, so it should ideally fail, right? So let's try to call it anchor test. So yeah, great. So make instruction was successful, and refund was also successful, but take failed, right? That's what we expected.